RHS Pre-calculus presents application of the Law of Sines.
Today we're going to learn about the Law of Sines and how to use it.
The Law of Sines states that in triangle ABC, sine of A divided by A equals sine of B divided by B equals sine of C divided by C. Here's how we find that law. The equation for the area of a triangle is 1/2 base times height. The base in this triangle is side C. Because this is an oblique triangle, we don't know the height.
So we create a right triangle. By dropping a line from angle C perpendicular to the base C, we create a right triangle with the height as the side opposite angle A. We know that the sine of an angle is opposite over hypotenuse, so in this case, sine of A is equal to height over B.
We rearrange this equation and state that the height h is equal to b times sine of A. Now we can plug this into the original equation for the area of a triangle to get area equals 1/2 BC sine of A. By using the same method for the other angles, we find that also area equals 1/2 AC sine of B and 1/2 AB sine of C.
Since each of these three equations is equal to the area of the triangle, they are all also equal to each other. So area equals 1/2 BC sine A is equal to 1/2 AC sine B is equal to 1/2 AB sine C. If we divide this equation by 1/2 ABC, we are left with area equals sine of A over A equals sine of B over B equals sine of C over C, the law of sines.
Now let's try an example. This law works directly for any triangle where angle, angle, side, or angle, side, angle is known. This example is an AAS triangle. Given angle C is 102.3 degrees, angle B is 28.7 degrees, and side B is 27.4 feet, we are solving for angle A, and side C.
We begin by setting sine of 28.7 degrees over 27.4 feet equal to sine of 102.3 degrees over side C. We cross multiply and then divide by sine of 28.7 degrees to find that C is equal to 55.7 feet. Next, since we know that the sum of the angles in a triangle is 180 degrees, and we know that angle B is 28.7 degrees and angle C is 102.3 degrees, we can subtract their sum from 180 and find that angle A is 49 degrees. And lastly, we set sine of 28.7 over 27.4 feet equal to sine of 49 degrees angle A over side A, cross multiply, divide by sine of 28.7 degrees, and find that A is equal to 43.1 feet.
Next, let's have a look at an example of an ASA triangle. In this triangle ABC, we know that angle A equals 43 degrees, side C equals 22 centimeters, and angle B equals 98 degrees. Thus, we are solving for angle C, side A, and side B. First, we subtract the sum of angles A and B from 180 to find that angle C is 39 degrees. Next, we plug the known values for angle C, side C, and angle A into the law of sines equation and solve to find that side A equals 23.84 centimeters. And finally, we find side B with the equation sine of 98 degrees divided by B equals sine of 39 degrees divided by 22 centimeters. Solving for side B, we find that it is 34.6 centimeters.
And there you go. We've derived the law of sines and detailed its application for angle-angle-side and angle-side-angle triangles.